Com Science 7. Chapter 11. Light, Shadow and Reflections.
Sources of light. A light source is any object that produces its own illumination. Throughout history, humans transitioned from simple flame-based tools like wood fires, clay lamps, diyas, and candles to modern electrical devices like LEDs and fluorescent tubes. Classification of light sources. Natural sources. These occur in nature without human intervention. Examples include the sun, stars, lightning, and bioluminescent organisms like fireflies. While the moon reflects light rather than producing it, it is often grouped here. Artificial sources. These are man-made using technology. Common examples include incandescent bulbs, neon lamps, and street lights. Luminous and non-luminous objects. Objects are classified by their ability to produce light. Luminous objects, like the sun or electric bulbs, generate and emit their own light. Conversely, non-luminous objects, such as the moon or books, are only visible when they reflect light from a luminous source. Measuring brightness. Luminous intensity is measured in lumens or lux. Historically, candle power compared sources to a candle's flame. Today, units like the lux define brightness on surfaces, with 1 foot candle equaling 10.76 lux. Light travels in straight line. Light follows a property called rectilinear propagation, meaning it travels in straight paths through uniform media without bending. Examples include straight sunbeams or projector rays. Because light cannot curve around obstacles, solid objects block its path, creating shadows, which further proves its straight line movement. Transparent, translucent and opaque objects. Materials interact differently with light and are classified based on their ability to transmit it. Transparent, these allow light to pass through completely, making objects behind them appear clear. Example, clear glass, air. Translucent, these allow partial light but scatter it, resulting in blurred images. Example, frosted glass, butter paper, opaque. These block all light, preventing visibility. Example, wood, metal. Mirrors are also opaque, reflecting light to create images. Reflection of light. Reflection occurs when light bounces off a surface. The amount of light reflected depends on the material. Polished surfaces like mirrors are excellent reflectors, while clear glass absorbs or transmits most light. We see objects only when reflected light enters our eyes. Laws of reflection. The angle of incidence equals the angle of reflection, I equals R. The incident ray, reflected ray, and the normal all lie in the same plane. Key terms include the incident ray, incoming light, the reflected ray, bounced light, and the normal, perpendicular line at the point of incidence. Types of reflection. Regular reflection occurs when a parallel beam of light strikes a smooth, polished surface, like a mirror or still water, and reflects as a parallel beam. This process allows for the formation of clear images, which is why we can see our reflection in new utensils or glass. Irregular, diffused reflection happens when light hits a rough surface, like walls, trees, or stones, and scatters in different directions. While it does not form clear images, it is essential for general illumination, spreading light across a wide area. Crucially, diffused reflection still follows the laws of reflection. The scattering is simply due to surface irregularities. Plane mirror. A plane mirror is a glass sheet silhouetted on one side and protected by dark paint to ensure maximum reflection with minimal absorption or transmission. It uses a smooth surface to produce clear, undistorted images. Characteristics of the image. Laterally inverted, the left and right sides are reversed, which is why ambulance is written backward on vehicles. Same size and erect, The image is upright and identical in size to the object. Virtual. The image cannot be caught on a screen because rays only appear to meet behind the mirror. Uses. Plane mirrors are essential for grooming, shop decoration, periscopes, and eye testing charts. Pinhole camera. A pinhole camera is a simple light-tight box that uses rectilinear propagation to form an image. Light rays from an object pass through a tiny aperture, crossing each other to project an inverted, real image onto the opposite screen. Key features and factors. Working. The small hole admits narrow light bundles while blocking others to maintain sharpness. Internal matte black walls prevent reflections. Image size. Moving the object closer or lengthening the box enlarges the image. Moving it away shrinks it. Pros or cons. It requires no focusing and safely views bright objects like solar eclipses. However, the resulting image is often dim and lacks fine detail compared to lens-based cameras. Multiple reflections. Multiple reflections occur when light bounces repeatedly between two or more mirrors. This process follows the law of reflection at every bounce, potentially creating an infinite series of images when mirrors are placed parallel to each other. The periscope. A periscope is a practical application of multiple reflections. It uses a tube with two mirrors set at 45 degrees angles to allow viewing over or around obstacles. Light reflects from the top mirror down to the bottom mirror and into the observer's eye. Uses. Submarines. To observe the surface while submerged. Defense. For soldiers to watch from trenches safely. Engineering. To inspect hidden or tight machinery parts. Kaleidoscope. A kaleidoscope is an optical instrument consisting of a tube with three mirrors arranged in a triangular form. It contains colorful fragments of glass or plastic that tumble as the tube rotates. How it works. The device relies on multiple reflections to create intricate, symmetrical patterns. Each shift of the colorful bits results in a new, unique design. Uses. Education. Demonstrates principles of reflection and symmetry. Art. Inspires designers with endless pattern variations. Entertainment. Provides visual delight through shifting colors and shapes.